everyone. Today I am going to continue the electromagnetic field theory on the topic of dot product. So here I will explain what is mean by the dot product, then we will continue this numerical which I have solved just now here. Okay, in the dot product we are interested to find out the angle between the vectors. If you observe this figure, here the A is the vector, B is also the vector, and the theta is the angle between the two vectors. And this theta is nothing but the smaller angle between the vector A and the vector B. So A is the vector, B is the vector, and theta is the angle between these two. So how we can calculate this angle so that we can calculate the dot product. So A and B is my two vectors. So A dot of B, if I am, many of the textbook they are taking as a bar. Okay, if you are writing well and good, if you are not writing, doesn't matter. The A bar dot of B bar, or simply A dot B is equals to mod A dot of mod B cos theta. So here A and B are the vector, mod indicates as the magnitude, and cos theta why we are taking, just because to calculate this angle theta. So now pay attention here. A dot B will as it is. This term will come into the denominator, mod A dot of mod B is equals to cos theta will as it is. Now just focus what is our intention, to find out this theta. So this theta is equals to, cos will go here, so theta is equals to cos inverse of A dot B will as it is divided by mod A dot of mod B. These are the magnitudes and these are the vectors. You may take like this also, okay, doesn't matter. Okay. Now forget about this figure. Come to the numerical here. So in short, we have calculated this theta, okay, that is of a smaller angle between the two vectors, the vector A and the vector B, and also we have simplified with the help of the formula, that is nothing but the dot product. Now just solve this numerical. So what is mentioned? Given points, here the points are three, that is A, B and the C. In the A, what they mention? 2, 5, minus 1. A in bracket 2, 5, minus 1, comma B in bracket 3, minus 2, 4, and C in bracket minus 2, 3 and the 1. So these are the 3 points given. What we need to calculate? Calculate the A part, RAB dot of RAC. So if you observe this figure and this point, so A, B and C, 3 vectors are mentioned in the numerical. But we have in this figure, you will be able to observe only the 2 vectors. That we will see how it is possible. Second, what you need to calculate? Angle between the RAB and RAC by using the dot product. Okay. Second, the length of the projection of a RAB on RAC, and the last vector projection of a RAB on RAC. What is the length of the projection and what is mean by the vector projection? That is possible with the help of, to understand with the help of this figure. In this figure, if you observe, this figure is related to this numerical only. So what is here? A is my vector, B is also my vector, and the third vector is nothing but the C. I am interested to calculate the angle between these vectors. So my AB is nothing but the total length here. You may take here wherever the length is there. So till that you may take the length between these two. The projection, the C part is nothing but projection on the AC. So this is nothing but the length of the projection. This length of the AB which is projected on the AC. Okay. Now, in the second case, vector projection. Vector projection means entirely this AB of this entire vector. Vector means again that equation dot of unit vector. Okay. So A, B and the C, wherever that projection is going on, that point is nothing but my P, and you are going to calculate this theta. So length, this will be the RAB and this entire length will be your the RAC. Now how we can start? All of you pay attention here. How I am going to start? In my the point A, RAB dot of RAC. The dot product is going on between the 3 vectors. AB is first, second is the AC. Okay. So first of all, how we can calculate the length? Already we have done in the various numericals how we can calculate the length. RAB is equals to, A is the source, B is the destination. Yeah, first to second. Okay. So how we can calculate second minus of first? That is the RB minus of RA. What is my B? B is mentioned already. 3 minus 2, 4. 3 minus 2, 4. What is my A? A is a 2, 5 minus 1. 2, 5 minus 1. Now, these are the points, these are the points. Convert this point into the equation, convert this point into the equation. How I can write in the equation? This is the related to the x, this is related to the y, this is related to z, similarly x, y and z. How I can write? This is the 3ax, ax direction, minus 2ay direction and the 4az direction. Similarly, minus sign is there, so second minus of first. So 2ax, 5ay minus az. This is in the x, the y and the z. Now subtract. So 3ax minus 2ay, 4az minus 2ax minus 5ay minus become as a plus of az. Now see here, this 3ax and minus 2ax will become as a ax. Now minus 2ay and minus 5ay will become as a minus 7ay. Now 4az plus of az will become as a 5az. So this is the length of a RAB. That is nothing but this length, RAB length. Similarly, come to the next. That is nothing but directly it's not possible to calculate the RAB dot of RAC. So individually we need to calculate. So RAB finished. Now come to the RAC. RAC. A is the first, C is the second. Now second minus of first. So RC minus of RA. What is my RC? Minus 2, 3, 1. So here minus 2, 3, 1. What is my RA? That is 2, 5 minus 1. So 2, 5 minus 1. Now just convert these points into the equation or the vector. Convert these points into the equation or the vector. So here minus, this is x, y, z, x, y, z. So minus 2ax plus 3ay plus of az. 2ax, 3ay, az. So 2ax, 5ay minus az. Now after these two, simplifying these two equations, subtraction is going on, okay, between these two brackets. So 2ax, 3ay, az will be as it is, minus 2ax, minus 5az, minus of az. Now minus 2ax will become as the 4x, 3ay and minus 5ay will become as a minus 2ay, az and this az will become as a 2az. Okay, now it is possible. RAB dot of RAC. Now what is RAB? Ax minus of 7ay plus of 5az here written dot of minus 4ax minus 2ay plus az written here. So in these two brackets what is going on? That is nothing but the dot product. Dot is a mention. So always remember here what I done. Nothing means 1. Here nothing means 1. So 1 is multiplying with the x. Already we have simplified in the many cases. We know very well in the dot product. Ax dot of Ax is equals to Ay dot of Ay is equals to Az dot of Az will become as a 1 in the dot product. Similar, okay. So Ax will become 1. So 1 into minus 4 will as it is. Now second minus 7 and here the minus 2 because Ay will become as a 1. Again the plus sign will be there. So 5 and the 2. 5 and 2. Az will become as a 1. So what will be the case? After simplifying RAB dot of RAC, you will get the answer 20. Now come to the angle between the RAB and the RAC. Already we have done here the formula. So cos theta is equals to, here the 3 vector, that's what RAB dot of RAC divided by mod of RAB dot of mod of RAC. So already we have done RAB dot of RAC is nothing but the 20 divided by RAB. Where is my RAB? Here, this. So mod if you are taking the root of Ax square, Ax means nothing means 1. So 1 square minus 7 square plus 5 square. 1 square minus 7 square, 5 square. Now dot of RAC. Where is my RAC? Here. So minus 4 square minus 2 square plus 2 square. Minus 4 square minus 2 square plus 2 square. So here will be the root of 75 and root of 24. So after simplifying 20 divided by this case, you will get as a 0.471. That is nothing but the cos theta. But the theta will be equals to cos inverse of 0.471. So you will get as 61.87. Now the section C, that is the length of the projection. What is mentioned here? Length of the projection of a RAB on a RAC. So RAB which is projecting on the RAC. So AC will be my unit vector. RAB dot of AC. So AC already we know very well. In previous lecture also we have done. So any unit vector, if AC is there, so that will be, you can calculate the vector divided by mod of that is nothing but the magnitude. Similarly here RAB AB dot of AC. So AC is nothing but the RAC divided by mod of RAC. RAB dot RAC. Already we have calculated 20. So this 20 will become here divided by mod of RAC. Mod of RAC. Where is my RAC? Here. Minus 4 square minus 2 square plus 2 square. Again root of 24 you will get as a 4.08. Now the last part, that is a vector projection of a RAB on the RAC. Here we were interested in the unit vector, whereas, or you may say the length simply. If you are talking about the length, definitely we will get the magnitude. But if you are talking about the vector, definitely we will get the equation in the form of all directions. That is the x, y and the z. So RAB dot of AC. How it is possible? This part is this only. This much part is this only length. Dot of again. Dot of AC. So here already we have calculated 4.08. Done. Now come again once again. AC. Unit vector AC. So here RAC divided by again the mod of RAC. So RAC. Where is my RAC? RAC. Already we have done in the RAC here. Okay. We have calculated na RAC. That is nothing but the minus 4 minus 2ax plus 2ay. Minus 4ax minus 2ay plus 2az. So if we are interested to calculate the magnitude, the root of first term square, second term square, third term square, minus 4 square minus 2 square plus 2 square. So it will become as a root of 24. So here in the outside the bracket 4.08, and thus it will be entirely this equation that will be multiplied with the entirely. Now just remove this root, calculate this one. So minus 4 divided by so and so of a of x, minus of 2 divided by the value of this one a of y, plus 2 divided by this value of a of z. Entire equation will be multiplied with a 4.08. Finally you will get as the vector projection of RAB on the RAC is nothing but minus 3.33ax minus 1.66ay plus 1.66 az. So in this way you can make you can observe here the difference between the length and the vector. So length only gives the magnitude, whereas the vector gives the entire equation in the form of the all the direction, that is the x, y, z. Why we are saying the x, y, z? Just because the Cartesian or the what you can say rectangular form we are taking here. So in this way we have simplified the dot product. Okay. So for this lecture, this one is sufficient. In the next lecture we will continue the dot product, few numericals as well as the cross product. Thank you.